All right, let's move along. Where caution applies. So if we have something like this, so we're going to do direct substitution. We plug in 2. Let's see what happens. We get 2 squared is 4 minus 6 times 2 is 12 plus 8. Okay, that's easy. That is going to be 0. Okay, easy. That's what we had before, I think. And then 2 squared minus 4, that's 4 minus 4 is 0. Whoa, wait a minute. Okay, so Mr. Fincher told me that if 0's on the top, we have 0. If 0's on the bottom, we have does not exist. But what in the world is this 0 over 0? If you get 0 over 0, oh wait, there's a play button here. Let's check and see what this says. Oh, it does that. Oh, whoops. Okay, so I'll just pretend like you didn't see the bottom part. Then you must try an algebraic method, okay? That means that you're not doing anything wrong. You just can't use direct substitution. Your answer can never be 0 over 0. So we have to do something else. So if you ever see 0 over 0, you can think needs more math. Everybody say that. Needs more math. Okay. Good work. All right, let's go ahead and see what are the 3 things. It's actually what we worked on, what we saw on the front. So factoring, rationalizing, or simplifying a complex fraction. All right, let's check and see how we do each of these. So for number 9, again, we're going to check and see if it's 0 over 0, which I think let me explain. Oh, that's a cool color to put on top of itself. So 0 over 0 is actually called indeterminate form. I think that's how you spell that. I hope it's how you spell it. If it's not, sorry about that. But it's the idea that we need to go further. So if we have indeterminate form 0 over 0, more math's required. Let's check and see if we have indeterminate form with number 2. This is exactly what we saw before. So we know that's 0 over 0. So that means more math required. Now, in looking at the different strategies, we have factoring, rationalizing, which means there's something with the square root. Simplifying complex fractions, that means there's lots of division lines. This looks to me like factoring. So let's go ahead and see if we can factor this. So limit as x approaches 2 of, that's x, what would that be? That would be x minus 4, x minus 2. That's how that factors on the top, right? 2 numbers that multiply to make 8 and add to make negative 6. And then on the bottom, x plus 2, x minus 2. Oh, what do you notice? You notice that x minus 2, you can cancel because they're on the top and the bottom. And when we talked about rational functions way back, that is actually a whole. So wholes have weird properties. They end up looking like this. So if we went ahead and took this, we can actually plug in 2. So that would be, what would that be on the top? 2 minus 4 is negative 2. 2 plus 2 is 4. So you get negative 1/2. All right, so what's actually happening here is you got some line and you got some hole at 2. And so it's approaching it on either side. So the limit exists. It's just we got to work a little harder to get there. So it ends up being negative 1/2. So we'll say that this is negative 1/2, which is not supposed to be above the x-axis, but we're okay. All right, number 10, I'd like for you to try that on your own. You will factor and cancel something. Pause the video and try it on your own. Okay, so the denominator is the only thing that factors. So that'd be x plus 4, x minus 4, cancel, cancel, and then you have the limit. Oh, not red. You have the limit as x approaches negative 4 of 1 over 0. Oh, what is, no, not 1 over 0, 1 over negative 8. Sorry. And then you end up with negative 1/8 as your final. There are some, maybe there's some confusion on this. You can take the limit of a value. It's just that value. Please don't drop the limit notation early. If you have x's, you need to have a limit notation. If you have a number, you don't have to have limit notation, but it just keeps it all safe. So don't drop your limit notation until you get a value like this. So I didn't have to have the limit on the second line. Ooh, okay, so number 11, this is not factoring. Do you guys see it's a square root of x plus 1 minus 1 over x. Let's go ahead and see if this would result in an indeterminate form. If I plug in 0 here, I'm going to get square root of 1 minus 1, so that's 0 over 0. So yep, indeterminate form. Let's see what happens if I, well, it says rationalize, and then it says think conjugate. Ooh, we've used conjugate a lot, but that usually means that a sign changes. So for this one, in the numerator, if I were to get rid of the minus, I'd have a plus, I guess. So limit as x approaches 0 of square root of x plus 1 minus 1 over x times square root of x plus 1 plus 1. That, to me, is kind of our idea of a conjugate. And then we're able to say, okay, if I multiply that through, okay, FOIL a little bit, as x approaches 0, this would become x plus 1, right? Square roots and square roots, if they're the same thing, the square roots go away. This times that is root x plus 1, and then this is minus root x plus 1. So that goes away. That's nice. Minus 1. Oh, okay. So that simplified a lot in the numerator, but the denominator is still super ugly. And we're going to just keep it super ugly because I don't know what would make it any prettier. Distributing the x is not going to make it pretty. It's going to make it even uglier probably. All right, if I do this, we get x over x. Aha. Wait a minute. I think I see what's happening here. We're able to cancel out something else, x and x, just like we did for the factoring. And I believe that will give us, if we plug, I think now we can plug in 0. So limit as x approaches 0 of 1 over, that's 1 plus 1, so 1/2. Again, this would yield some kind of whole because we canceled, and then it would just be approaching it on either side of 0 to be 1/2. Pause the video and try number 12 on your own. All right, for us, number 12, when you take the conjugate, multiply by the conjugate, your conjugate's going to be x plus 4 minus 2. Oh, wait, we forgot. You need to check and see if it's 0 over 0. If you plug in 0 here, 0 over 0. Okay, good. Sorry about that. All right. X, and then the conjugate's going to be x plus 4 plus 2, and square root of x plus 4 plus 2. So when I multiply that through, you got x plus 4. The two center terms canceled like we saw before because we have positive 2 root x plus 4 and then negative 2 root x plus 4, and then minus 4. X plus 4 plus 2. And let's see if something pretty happens in the top. It looks like it will. I just got x over. And then this guy cancels. So we end up with, plugging in 0, I end up with 1 over square root of 4, which is 2 plus 2. So my answer is 1/4. Nice. All right, so conjugate, not too crazy. There's big mistakes that you could do if you end up trying to multiply this out. If you do that, you're going to just get lost. This number should cancel from the top. So if you're multiplying it out, you won't see that it cancels and you'll get super mad about it. So don't do that. All right, the last possibility for us to do is something that looks like this. We are not able to think through, can't factor this. There's no conjugate that we're thinking through with this. So let's go ahead and try something else. And actually, we're going to start this on the next video. So I will see you in just a moment.